Thanks everyone for joining. It seems like a exciting but potentially long day for all of you. So before diving directly into the product, I'm going to give you a little background on why we built Scite, who I am, the problems we're trying to solve, and how that's evolved over time. And so my name is Josh. I'm based in New York. I am a cell biologist by training, so I finished a PhD back in 2015. Scite really started in response to growing concerns around trust and reproducibility. And as the questions from the last section or session suggest, trust is still a big issue, especially with LLMs. And so we'll talk a little bit about how we've focused on citations and how that helps with looking at research articles, researchers, journals, institutions, et cetera, but also how that helps in the new world of generative AI with LLMs. Before that, why did we start Scite? Well, in 2012, I was at the bench doing a lot of microscopy, looking at cancer cells. This paper came out. This is published in Nature, is published by two VPs out of Amgen. And what they report in this paper is essentially that a lot of the studies that they try to validate in-house to take down, various applications to try and create drugs, they couldn't, right? So they could not reproduce studies from major cancer studies. And so this got a lot of attention, A, because it was in Nature, B, because it was a big claim. 90% of studies not being able to be validated is very problematic and worrying, not just for money, but also for the people in this. This was seen similarly, maybe less of a splash in Nature Reviews drug discovery, also by a large pharma looking across different indications. And so from this, and really starting to look across different disciplines like psychology, et cetera, there was this dubbed reproducibility crisis, right? We're spending a lot of money, we're doing a lot of research, we are potentially cutting corners or at least publishing things that don't stand up when others try to repeat those claims. And so that's quite problematic if you think about that. And so that got a lot of attention from me, from consortia, from everyone really putting up different suggestions on how to reproduce or how to solve this. And so back in 2014, over a decade ago, me and my co-founder Yuri Lazipnik, who was a professor at Cold Spring Harbor for 20 years and then moved to Yale, wrote a paper. And we actually wrote a paper on my first company called The Winnower. The idea behind the paper was that not all citations are the same. We need to identify as well as incentivize good reproducible research, not just flashy research, if you will. And so in this, we proposed that the R factor would be a new metric that indicates whether a report or conclusions have been verified. And to do that, we wanted to look at the citations. Kind of funny, in that paper, we suggested that someone else do it because we didn't think we could actually do that. And so we said the government should do this, NCBI, or Elsevier or Thomson Reuters, or someone with a lot of resources should do this. Ultimately, we started to work on it on the side. You can see it took a while, but this was Scite kind of day one, so back in 2018. And what we're showing here is a list of citations, but what is crucially different from other citing indexes is that you're seeing the context, right? And so this is nothing fancy. It's just showing snippets of text extracted from the full text, and then you see a classification of confirming or mentioning, and you can see where that citing paper is. So when I first saw this, it really kind of opened up my eyes and said, okay, I think we're on to something here, because now I can look at 4 papers in a second or a minute, read exactly what they've said versus, potentially, I would say hours in some cases looking at this. And so we built Scite, started working on it full time since then, and have really kind of come a long way. And so the way that I like to show Scite is to, really show the world as it exists without Scite, and then to show it through the lens of Scite. And so I'm going to switch now to a live demo, and I would encourage any and all questions as we get going, and I can answer them at the end, or I can also pause and answer them throughout. And so here is one of the main studies coming out of my PhD. There I am. You can see I did my work at Virginia Tech. We collaborated with the hospital in Portugal as well as the lab at the NIH. You can see where it's published. So it's published at eLife, the date. You can also see how many times it's been viewed, how many times it's been downloaded, and then how many times has it been cited. And so generally, this is what we look at, whether we're in a reference manager, whether we're on a publisher page, whether we're in some other tools. this helps guide us. Is this something we want to read? Is this something we think is trustworthy? Has this been received well by the community? I would say in most cases, we probably just look for this button, download the PDF, get it, move on. In some cases, you glance at this. But historically, we haven't clicked through and opened what 93 different documents say, right? That is too much work, so much so that publishers now literally just display numbers in many cases, right? So eLife, you can't even click through to see which 93 papers those are. Other publishers will show, a list of citing articles. You might be familiar with Scopus or Web of Science, or also how Crossref displays it. But we've really moved towards citations just being a superficial number where high is good and low is not so good. And so we wanted to change that, right? Because behind each of these citations could be 5 years worth of work, maybe more. There could be a lot of money, there could be a lot of effort. That could help with your interpretation of the study that you're interested in. Maybe it surfaces competing information, supporting information. Maybe it's been cited in the methods section, etc. And so this is one entry point to Scite. We have a browser extension which will show you our information basically anywhere you're reading a scientific article online. So whether that's publisher page, whether that's PubMed, whether that's Google Scholar. The first thing to note is that we're very comprehensive. That's been a core focus of ours since day one, is making sure we have good coverage. You can see that we have 106 documents citing this versus the reported 93 from eLife. We then have a breakdown of citation statements, and this will become more clear what I mean. What is a citation statement when I click through? Sometimes that's more than the number of documents, and sometimes that's less, depending upon how many we've processed or how much we have access to. So if you click this, it brings you over to Scite. What you can see is that we have basically the same metadata as the version of record. So we have the title, we have the authors, we have the abstract. If you scroll down, you can see that we do have a list of citing documents. But what is unique to Scite and really differentiates us, as Togrim said, is that we have the citation context. And so presumably no one on this call has read my study. But now in one click, you're able to see that here's a paper. There's no self-citation flag. There's no shared authors here. What they're saying is in agreement with previous work, and then they cite Nicholson et al. The trisomic clone showed similar aberrations, albeit to a lesser extent. And then they highlight where their data is. It's in supplemental figure S2B. And so this context, this text, was extracted from the full text of the article, and it was extracted from the results section. We then have a classification indicating if there's supporting or contrasting evidence. So getting back to us trying to surface, is this paper trustworthy? Has someone challenged this? Has someone supported it, etc.? So this, what we call smart citation or next generation of citations, is really kind of the building block of Scite, showing the context, allowing you to see where it's been cited, and then allowing you to look at it for a variety of different ways. And so here, this is a results section. You can see they found something similar. Maybe if you filter by the introduction section, you can now see how are people interpreting this. And so these are not AI summaries, but these are kind of single sentence summaries from the literature. And you can just simply read that where it says, aneuploidy has been shown to cause genetic and chromosomal instability in both yeast and mammalian cells. This is my study highlighted in 10. If you highlight over here, you can see that there's also studies, one published in Science and one published in PLOS Genetics, highlighting that something similar has been found in yeast, right? And so we were looking at human cells. And so it's a good way, not just for looking at supporting or contrasting evidence, but also helping with interpretation and really allowing you to very quickly see what does the literature say about this article of interest. You can search through these things and say, okay, I want to only narrow it down by yeast. You can filter by sections, as I've just shown you, by types, by years, by article types, self-citations, etc. You can also do a nice visualization. So to me, this is maybe pretty easy to understand, right? We're showing a citation graph, but what we're showing is the exact sentences where the citations were made. In this case, here's a preprint, and what you can see is that papers don't just only cite once, right? It's not just a flat link, there is a link, but they can sometimes cite multiple times. Sometimes they can have a supporting citation as well as a contrasting citation in the same paper, or they can make multiple in-text citation statements. And so this, while easy to understand, is not easy to get to, right? As we highlight here, we need access to the full text of scholarly documents. And that means going beyond just open access articles that we can grab. And so to build Scite, what we've done, since day one has been to partner with publishers. And so we've been Scite.ai before everything was .ai. And that is largely because we've used a lot of machine learning, deep learning, which I'll talk about in a second. But the first step towards building Scite and to really showing the context of citations is to get access to the full text. And so naturally, we started with open access content. We could build out a prototype. We could show this prototype to publishers, and then we could start to sign indexing agreements. And so we've signed about 40 different indexing agreements. This is not an exhaustive list across all different disciplines to gain access to the full corpus of publishers' content. And so subscription-based content as well as open access content. That's going to become critical as I talk through Scite Assistant and really a big differentiator of Scite. Right? We didn't just plug into an open access source and say that's good enough. We've done a lot of legwork, and we continue to do new indexing agreements directly with publishers. And so this is what it looks like. And again, we're continually signing new indexing agreements with publishers to expand the coverage. Once we get access to the full text of the literature, we then need to process it. And so again, since day one, we have utilized a lot of machine learning to extract out this information at scale. Most content is still in PDF, especially pre-2000. And so there's really no way around it. And so this is a visual representation of what it looks like. PDFs can be 2 columns, single column. They can have 3 columns. There are thousands of different reference styles. That produces a challenge for processing 65 million plus PDFs. And so there's a lot of machine learning that goes into identifying tang et al. As a reference. We then have to match that to the correct reference in the reference section. We then have to take that information and match that against the correct metadata from Crossref or DataCite, identifying, okay, here's the linkage. We then have the sentence and the sentence before it, as well as the sentence after it, extracted. And so generally, this citation context makes up 3 sentences. We then have a deep learning model that looks at the text in that snippet to identify, is there supporting or contrasting evidence, right? Are they supporting this, and do they indicate that there's evidence or analysis behind this? And so it's not as simple as, hey, I like this article. It's not positive or negative sentiment. It is really looking at the rhetorical function. Is there supporting or contrasting evidence? To build out and to train this deep learning model, we analyzed members of the founding teams of PhDs or MDs. We read roughly 40,000 different citation statements across all different disciplines. We kind of built this, it felt like a video game where a new snippet would appear and then we'd read it and then score it. We did that at least 2 different experts having to agree upon that citation statement. In some cases where it's hard for humans, there's as many as 10 different experts. That training set then goes towards feeding the deep learning model, which does this at scale. And as you remember from the last slide, it's necessary to do this, not because we are AI, but because we're talking about 1.3 billion citation statements extracted from dozens of millions of full text articles. We do have a holdout set of 10,000 annotated citation statements that is never touched or added to the training data, and that's used to optimize for precision and recall. We have, as researchers, actually published a paper on this, which we think is important towards building trust, right? How did we build Scite? What are the limitations? What has historically been done on this place? And so that allows us to get here, right? So all this legwork, going behind a paywall allows you to build out a complex citation graph. In addition to this, as citations are not just on individual articles, you can look basically, anywhere you might be interested. So maybe you want to see, what has Aaron published? This was an undergrad in our lab that later went on to do a PhD at UCSF. You can see how many papers they've published, how they've cited others, and as well as how they've been received. You can then organize these things. And again, not just look at, hey, this person's published a bunch and they've got a bunch of citations, but what do those citations say and how have they been cited? If you're interested, you can also look at this information in aggregate at the institutional level. And so here is University of California, San Francisco. You can see this breakdown of citation types. We've done a lot of work really making sure our editorial notice data is good. We've even published a paper on that, where the code as well as the data is open, because we don't think anyone should have a monopoly on this information. Critically, this will also show up on our browser extension. And so you can see that here But if you're on a publisher page, you'll also see a red X. And so that's useful because publishers are notoriously not great at highlighting that they have retracted a paper. Going down, we have, and this is really pushing back at the impact factor a bit, created this metric. This is essentially kind of like the R factor from that paper in 2014. It's really just a simple ratio showing supporting over supporting plus contrasting sites. And you can look at that in the same buckets as the impact factor and look at that over time. You can see who's publishing in this area, and then you can look at this table of articles. And so for this, we have virtually any journal you might want to look at. So you can look up any journal here. You can filter and see, okay, which journals have the most citations. Nature, Science, PNAS have a lot. You can also do that for virtually any organization as well as any institution. And so here you'll see a variety of different universities. You can also look at private organizations as well. In addition to this, because we have a pretty unique data set, this allows us to do some pretty powerful things with search. And so say I'm interested in chromosome segregation. Here I've just done a simple keyword-based search, right? No fancy AI here. It's just, again, a simple keyword-based search. What is powerful about this is that you're seeing these title matches, you're seeing these abstract matches. What you can also do, though, is filter it for all. And this will allow you to see directly into the full text of article. So how is this being discussed in the article before potentially having to open all these dozens of articles? And so this is a small nuance, but it's kind of like this X-ray search, or I haven't found a better way to describe it. But I think allowing you to see rich contextual insights before having to open 50 tabs on your browser does save you time and will help you identify, is this relevant? Is this something you want to look at more closely, where you do potentially want to print this out and read the full text or add this to a reference manager? So that unique data set also allows you to look at this in a variety of other ways. So you can see who's publishing on this. Maybe you want to say, okay, I just want the exact match of this. So you can use Boolean operators. We have an advanced search query builder, everything you might expect. And what you can say is, I want to see, not just who's publishing on this, but maybe who's publishing highly supported work. And so you can filter this and say, only show me papers that have at least 3 supporting citations. This narrows this down, and you can see here, this is actually my PhD advisor, who's publishing highly supported work in this area. If you want to find gaps or where there's potential debates, you might as well say, okay, let me find where there's contrasting citations. And this is now not looking at the paper, but it's looking directly at the citation statements themselves. And so let me filter this here. And you can see here now you're finding where, unlike previous studies demonstrating that elevating chromosome missegregation leads to cell death, this change in chromosome missegregation is not uniformly lethal. And so here you're finding debates, right? Gaps in the literature. This is areas where you might want to investigate more, or areas where you might call into question the claims of some of these studies. And so this search, is a pretty powerful way of navigating through a variety of different articles. You can build up custom dashboards. And so I showed you a dashboard for a journal, and I also highlighted that you can look at dashboards for institutions. You can also create a custom dashboard from our search, right? And so here's a chromosome missegregation dashboard that, again, will show you this information in aggregate. You can share this with colleagues, etc. Because many of us are talking about reference managers on this demo day, we do also allow you to bring in information from various reference managers. And so here's my different dashboards. If you want to bring in or import information, you can do that directly from Zotero, Mendeley. You can also do that directly from tools like PubMed or other reference managers by simply copying a list of DOIs. So pretty much every tool allows you to export out metadata. Here you can upload that list and create a custom dashboard, whether that's from PubMed, whether that's from a systematic literature review tool, or virtually anywhere there's a list of articles. And for organizational clients, you can create pretty large dashboards up to 50,000 different DOIs. So this is a good way of bringing in information or seeing this information in an aggregated view. And so this has been kind of, I would say, the core focus of us is really, creating this next generation citation, allowing you to look at how any individual article has been cited, etc. We do work directly with publishers to display this information on the version of record. And so here's what it looks like. Oops. So here's what it looks like on Wiley. You can see that we're not just interested in kind of being this interesting side case, but really partnering with publishers to bring in that next generation of citations. And so Wiley was an early adopter of this. This is actually, I would say, still says beta in many cases. Here it looks like on Royal Society. You can see we're showing the documents. They sometimes leave us along traditional citation indices, which is totally fine. And you can see there's a variety of different ways of styling this. And so that is, again, towards our aim of really trying to incentivize, hey, it matters, these debates. Let's surface these debates. Let's also, identify when papers have been supported or challenged. And so this was, I would say, the core focus of the business and the tool and the product for the first 4 or 5 years. In comes ChatGPT, right? Very easy to use, very powerful, very flexible, but very hard to trust. And so what we said was, what does ChatGPT need, right? And what has it started to really utilize over the course of a few years? Well, if you think about it, it's citations, right? And so early ChatGPT, you would put in a prompt, you put in a question, it'd give you an answer. It didn't link out at all. And so it was, to whoever asked the question in the last session, it was very prone to hallucinations. It was only based on training data. It was not utilizing any information beyond that. ChatGPT, other tools have gotten better, of course. It now does go out to the web, but it only goes out to the web. And of course, there's some articles on the web, but there's not all articles on the web, or they're not all easily accessible on the web. And so we have launched Scite Assistant, which is effectively like a ChatGPT for research, that allows you to go beyond just blog posts, the web, and to really look at direct information from scholarly articles, those that are open, as well as those that are behind the paywall, looking at our unique data set that we have, and which I showed you for the article level as well as search. And so I'll now walk you through a variety of different use cases of how Scite Assistant can be used. So you can say, does trisomy increase the rate of chromosome missegregation? And so in this case, you don't need to know what a Boolean operator is, right? It's a plain language question. You can give it a prompt. I'm going to walk you through the settings in a bit, but for now, I'll just highlight them and hit run. And so what this does is, this is RAG, Retrieval Augmented Generation. It's basically taking the prompt. It's generating a search strategy here. You're going to start to see that search strategy. That search strategy is going to run over our data set. So it's not going out to the entire web. It's only based on scholarly documents. It's looking at effects of trisomy on chromosome segregation, chromosome segregation errors in trisomic cells, aneuploidy and its impact on chromosome segregation, etc. It's then starting to compose this response. And once it starts to do that, it will continue to go. It will do some fact checking, right? And so this really is kind of the differentiator of Scite, is that because we spent so much time signing index agreements with AI rights since day one, we have really unique access to do this. And so here you can see that maybe I kind of knew where I was going with this question, because it's utilizing my study. What it's doing is starting to answer this, right? So it says, Nicholson et al. Investigate this phenomenon, demonstrating that trisomic human cells exhibit significantly higher rates of chromosome missegregation compared to euploid cells. This is essentially exactly what my study found. What you can do here is hover over this, and you can read this information. And so this is, looking at how we are kind of validating it against. So it's not just, hey, here's a reference, trust that that reference says it. We have designed it for a way to allow you to very easily and quickly look at what does the article say versus what does the AI say. Beyond just looking at the context here, you can also see, okay, here's that article, here's how it's been cited. So you have the second layer of trust. And so this is really, a powerful way to start to kind of look at and utilize the best of, I would say, AI, that ease, that flexibility, that, quick answer, and kind of the best of scientific publications. That is, peer review, that is data, that's evidence, that's analyses. And you can see that this goes beyond just open access as well as abstracts. So again, really allowing you to have this differentiated approach. And so in this case, I only answered, or asked a pretty basic question. You might say, okay, that's great. It surfaced Nicholson et al. But why did it surface that? Maybe I want something from 2020 or later. Maybe I want something from 2025. And so under settings, we give you a lot of control, almost too much control where it's a bit confusing. But what we do here is allow you to say, okay, only give us references from, say, 2020 onwards. Or maybe I only want systematic reviews and I only want clinical trials used as evidence sources. And so you can specify the year range, you can specify the publication types, you can change the citation style, you can even select the different models. And I do recognize this is confusing, but again, we're trying to be flexible here, and we'll soon introduce different modes. But we allow you to use very advanced and very new models to apply, again, the best of AI advances with the best access of research articles. In addition to this, you can choose a shorter or longer response. If you select a different model, such as ChatGPT-5, you then will have a reasoning effort. And so you can say, hey, it doesn't need to run that quickly. I really want it to look very critically at each reference to answer potentially my very specific question. And so there's a ton of control here to help you as the user identify this is what's important to me. Because in certain cases, some people want highly cited studies answered, some people want specific journals answered, or maybe you want to start and say, I already know which articles I want to use, only use these 500 articles, or only use these 1,000 articles. And so this is a powerful way of kind of combining a very systematic search with the power of AI. And so this assistant settings, again, gives you a lot of control, something that is missing from a lot of generic or general tools to really navigate through the literature. Here, I've shown you, okay, here's a paragraph output. I think what is also potentially interesting, though, is the ability to say, okay, I want maybe not to look at writing a draft of a document or to get a paragraph output. Maybe I want to look at, data, right? So in this case, I'm going to say the same thing. Does trisomy increase the rate, of chromosome segregation? What I'm going to do, though, I'm going to clear this. What I'm going to do, though, is that I'm going to run this under a table mode. And so tables effectively is doing some data extraction. And so it's the same prompt. It's kind of the same strategy behind it, but the output you get is different. It's not going to give you these multiple paragraphs. It's going to look at each individual article that identifies from a search and try to answer that question. So does trisomy increases? And again, I promise I didn't know my article is going to be the first one. Here you can see that it's looking at my article, and then what it's doing is says, yes, trisomy increases the rate of chromosome segregation. In this case, again, you get to hover over this and see that information. And so this goes line by line through different articles. If you tell Assistant and say, hey, I have a dashboard with 1,000 articles, it will go line by line through different articles as well, up to 1,000 different articles. You can also say, I want to look at the methods, right? And so here's the method section. Maybe you want a standard response. Maybe you want just yes or no. If you're looking for numbers, you might say, okay, I just want to know the number of different patients in the study or things like this. You can select those different things. And what you can do is build out these columns. And so this allows you to really build out a table where you're getting potentially, up to 10 different columns, having the AI go through these articles, looking at the studies. And so here, again, this is very accurately describing what we did, right? We looked at colorectal cancer cell lines as well as amniocytes, and we compared the chromosome missegregation rates between euploid and trisomic cells, measuring missegregation rates as well as cytokinesis phenotypes. And again, you get to look at this information, reading through it, and making sure it's validly that. You can download this as a CSV, so you can take out this information, you can utilize it, etc. You can also share it, on the web or share it via email or internally on Teams or Slack and things like this. And so Scite has kind of evolved a long way from, okay, here's the next generation of citations, let's only look at individual articles, to really how can we provide trust around research, whether that is an individual article, whether that's a journal, whether that's an institution, or whether that's LLMs in this case. And so we're grounding LLMs in the scientific literature, which again, we have pretty unique access to. And so I'm going to open it up for questions, but before I do that, I want to kind of conclude on this study, which I think is pretty prescient and pretty cool to look back on. And so here is Eugene Garfield. For those of you that are not familiar, Eugene Garfield created the first science citation index, which has become Web of Science. Here he is, which was a talk transcribed into a paper back in 1964, talking about essentially what we built. In this, he says, it would be great if there was, however, it is interesting to speculate whether transformational or any other automatic analysis of such a paragraph could produce a useful additional marker. He describes these markers, which should appear in the published citation index along with the usual citation data. In the example, he gives a paragraph above, there would be a critique marker, or one of the several other terse statements like Mr. X is wrong, data spurious, conclusions wrong, or my very personal favorite, because I don't know how this would be classified, calamity for mankind. But then he concludes and says, the intelligent machine, again, this is 1964, this is not this year, the intelligent machine would examine a new document and generate a critical statement such as rather poor paper. And so here was this vision of looking at, adding differentiation to citations back in the 60s, and then even thinking about how intelligent machines could analyze these things to better provide answers and to better provide classifications. And so why this was hard to do was not all content was online, so you couldn't have the machine look at all these things very easily. It wasn't all open. And then the tools, the intelligent machines, they just weren't intelligent enough at this stage. And so I would consider ourselves pretty fortunate and pretty lucky to be starting Scite when we did, really in 2018, when deep learning models were readily available off the shelves, when there was enough open access content to start working to create this. And then, of course, when LLMs came in with our access. And so I will pause there and open it up for questions. Hopefully there's a lot or some, and then I can go deeper on anything else depending upon those questions. But I think this is generally a pretty good overview, talking about Scite, where it looks from the articles to Scite Assistant and beyond.
Yes, thank you so much, Josh, for the great presentation. For you, the attendees, now is the time to enter your questions in the question panel on your top right. So please do. I see we have some minutes before the next presentation. So, but Josh, I have a few questions here. How does you touch upon this during your presentation, but maybe we can focus on them. How does Scite.ai decide on if a citation is supporting, contradicting, or neutral? What algorithm are you using? Or
So that's a really great question. So it's not easy, right? As scientists, as researchers, no one forces us to cite an article in any way, right? We can write however we want, and we can cite it for a variety of different purposes. There's a whole citation ontology where I think there's about, a few dozen different reasons for citing an article. If you make a citation in the introduction section, that's going to be very different language than your citation in the method section. And so we were presented with the challenge of not just that there's a lot of content, but that there's no prescribed way of citing content, right? You can kind of cite it however you want. In addition to that, if you look from different fields, there's different ways of writing, right? A mathematician will write in a paper very different from a cell biologist. An economist will be very different from, a mathematician, etc. And so what we did was to basically first read these things manually as humans. So we would look at articles that we knew in our field. We would talk to colleagues, and we would read hundreds of papers, sometimes thousands of papers, just looking at text like this. And we would look at this and say, okay, can I as a human tell that this article is agreeing with this other article that it cites, and that there's evidence or analyses beyond that? So it's not just, hey, it's being nice to it, but is there supporting evidence or analyses? And so we came up with this rubric to define what do we mean by supporting and contrasting. And that was really looking at can, we, ignoring all this, we didn't have any of this, we just looked at these snippets, can we read this as humans and see that they're supporting and contrasting evidence? That way of looking at this, we basically read, again, these 40,000 different citation statements. That became our training data. That training data was used for Scite. Scite, I think comes from the Allen Institute, utilizes a lot of scientific articles, was one of the preeminent kind of deep learning models. That's used to then look at and analyze primarily text here and say, does that fit the training data, right? Is that looking like this? So it's not as just like there's two keywords here. It's not as simple as that. But it was taking our very highly curated data set, which took a few years, and again, training the model to look at that. It's not perfect though, right? It'll never be perfect because it's very challenging. And so we want to make sure you can read it yourself. So don't just trust us as it's supporting. You can see that information. We then show you this confidence number. This is output from the deep learning model itself. So the confidence that our system has that the classification is correct. Sometimes it gets it wrong. I would say, really it's gotten a lot better. It's pretty stable. We don't touch it so much at this point. But if you do see one that, that doesn't look like it's supporting, or that doesn't look like it's contrasting, we do allow you to flag these classifications and to say, this is actually just mentioning this paper. Here's the reason why. And then that is reviewed by humans, right, on the back end, where they will approve it or reject it based on that blindly. So two different, experts have to look at this. And so that is, published in our paper in a lot more details here that will really kind of give you this answer. It'll give you the precision, the recall scores, the different models we tried. This is the pipeline of what it looks like. And then also, I think pretty usefully, is this table here that will highlight here, this one is supporting, this one's contrasting, this one's not. Sometimes, it'll look contrasting, but it's important to understand why it's not. And so that's a really good question. And beyond that, I would say, while supporting and contrasting citations get a lot of information, and they're pretty rare in some cases as well, there's not a lot of deep learning here to say this is introduction. Actually, there's none versus discussion. But those are very different types of articles. So even if there's no, or citations, so even if there's no supporting articles, I think this is a powerful way to kind of digest the literature as well and to see different types of citations. It's a good question.
Yeah, thank you, Josh. There's also a question here, a multiple question actually, about which publishers and databases you're currently indexing. Yeah, and how does it work with publishers you don't have agreements with? And I would like to add to that. You said, I think, 1.2 billion citations in your database currently. Yeah. Do you know how many papers? I know that Semantic Scholar, the open access, is over 200 million.
Yeah, so it depends what you mean by that. So there's a couple ways of looking at this. So we have metadata on roughly 187 million. And so that's virtually anything with a DOI from Crossref or DataCite. We have that. That doesn't mean we have 187 million full text. Similar, Semantic Scholar does not have 187 million full text. And so I find, a lot of different groups kind of make these things intentionally obtuse to try and, put up a bigger number. And so we are, very comprehensive in terms of metadata. We have essentially every single title article that you'll find in Semantic Scholar, you'll find in PubMed, you'll find in any of these tools. That's really not much of a change. What is different is our full text index. And so this is, again, I don't think it's an exhaustive list, but this is showing a lot of the different publishers that we've signed agreements with. And so JAMA, so American Medical Association, Royal Society of Chemistry, American Chemical Society, Karger, PNAS, Walters Kluwer, Wiley, Microbiology, TEMA, etc. And so, while this is impressive, it's not every single full text article in the world. And so what I would highlight is, yes, we utilize all the open access content and then we build on top of that. And it is going beyond what other tools have, right? So while Web of Science and Scopus have been around for decades, they don't have the ability to show the context like we do. And so we are at their level. In fact, we're larger. And then we go beyond that by showing the citation context. We have extracted out from, we've analyzed, I think, 60 million PDFs. Not all PDFs have references, and so some won't be included. Some will technically fail, right? We are looking at some old documents in many cases. Our indexing agreement with Royal Society, we've extracted out citation statements that are basically 200 years old. And it's pretty remarkable to look at that PDF, and pretty surprising that we could even do that. And so we've extracted from, I think roughly, this is I think a bit out of date, roughly 35 million different PDFs have been extracted from this. And so what do we do when we don't have access to this? Here we've shown all this different context, we've shown all that context, etc. You can scroll back again. All these cases we've extracted this out. That's a funny one. We've extracted out citation context. In this case, we haven't, right? And so this could be A, we don't have the rights to it. We don't have an agreement with that publisher. B, we haven't processed it. Or C, it failed, right? Again, it's not the easiest thing to do when you're looking at so many different styles of PDFs. Some are OCR'd, some are not, etc. And so while we don't have access to full text of everything, we do still have a complete citation record. And so Elsevier is a great example. We don't have every single full text of their articles. We have millions, but we have all their references. And so that, again, allows us, on par with traditional citation indices, with this really rich component of 1.3 billion citation statements on top of that. And that is the largest out of any tool. Semantic Scholar, again, you can search 187 million titles, but they don't have, all this full text to search. They have a lot of it, and they have signed indexing agreements themselves, but it's a different way of looking at that. Hopefully that's clear.
Yep, thank you. There's also some question here about how to use it and how long time it will take to do a PhD literature review with your tool instead of other tools. I think if you can, do you have any tutorials, getting started guides?
Yeah, I mean, on the homepage, you're going to find a video of me with a bad freeze frame. This is like 5 minutes. It walks through this. We do have a variety of different tutorials. Under your profile, if you sign up, we have this welcome. It will show you how to do a lot of different things. You can find a variety of help and tutorials. There's short video overviews, like what is Cite, what is a smart citation, using this for literature review and critical analyses, creating dashboards, setting up topic notifications, etc. And so some of these, I would say we wrote before Scite Assistant, and so they're using traditional based searches. Under Scite Assistant, it's pretty powerful, where you can say, hey, I want to write a literature review, and to do this where I want it to be a long one, right? And so this is not going to give you a full literature review, and we don't say this should replace actual writing or even writing, a thesis or things like this, but it can help you get started in a variety of different ways. And if you select wrong, you can get basically a 15-page report that's fully referenced from the literature. And I would say beyond that, we work with a variety of different tools. So we're integrated in different tools. We have plugins in different tools like Zotero. And so Scite it can help you look at an individual article. It can help you start a draft of your thesis or of a paper you're writing, or it can help you answer questions better by just, looking through search using Assistant or using the tables mode. And so, there's much more to a PhD and things like this than just a literature review, but it should greatly accelerate a lot of those different things, helping you find, is this right? Is this wrong? Are there gaps in the literature I should look? And then can help you really, start drafting your documents as well.
Yes, thank you. Yeah, I find it very easy to start. As you have demonstrated, it's semantic search. You can just ask questions and get a really detailed answer. But there's a lot of settings and advanced features behind it. So
yeah, we're working on clarifying some of this too. I think this is, it's confusing, where it's like, okay, here's all these different models. Which one's best? And so we are constantly, doing user interviews and talking with our users to understand how are they using it, where is it confusing, where can we improve. And a lot of our work here is on Assistant, making sure those settings are clear, making sure tables, the UI, UX could be cleaned up a bit. And so we do love critical feedback, and we do love suggestions from users, because I think, we're still a small team, but that allows us to, directly make changes that matter.
Thank you. Here's also an interesting question. How do you identify predatory journals?
Yeah, so this is an interesting question, and it's come up. It's not something that we want to take on ourselves, and so it's kind of a slippery slope, right? There can be a clearly predatory journal. There could be some that are, some people think are predatory and others don't. There could be a good article in a predatory journal. There could be a predatory article in a good journal, right? And so it's not as simple as this journal is bad. In some cases it is, but in many cases it's not. And so we actually utilize our partnership with Cabell's, who had historically this black and white list. I think they've called it something else now, as well as Beal's list, to look at the ones that are obviously predatory. Those are then excluded from search and assistant. Retracted studies are also excluded from assistant. But we're leveraging basically the work from other groups that do this, where that's almost their entire focus. And so, you know, we do listen when librarians write and say, hey, we notice this journal is in here, we think it's predatory. We then will evaluate that on a case-by-case basis. But currently we really use lists from Cabell's, as well as from Beal's list, for those that are familiar with that.
Yep, thank you. Yeah, I think that's what we have. I have one, maybe you have touched upon this too, but just as the key takeaway from this webinar, what's the biggest differentiator with the Scite.ai compared to, for instance, Web of Science, Semantic Scholar, Google Scholar?
Yeah, I think it's this. I think it's, you know, really some of it's luck. You know, since the beginning, we've been Scite.ai. We didn't just tack that on when LLMs came. We've been applying AI to the literature, the full text literature, for, you know, years. And so we have really unique access to create a Scite Assistant to do things that other groups don't, right? Many other tools will just plug in to Semantic Scholar, which is easy and free and quite powerful, but it's only open access content, and so it limits you. And so everyone has access to the various LLMs. It's pretty easy to plug into those nowadays. Getting access to literature is much more difficult. And I actually think publishers are going to start to pull back some of their information from these open sources as LLMs start to integrate into them. I just saw an announcement this morning where Anthropic is integrated into PubMed. And I was just at the Frankfurt Book Fair, and, you know, what publishers are starting to do is say, okay, we recognize this content's being used in LLMs. We don't necessarily like that. And so they'll start to pull that back and only allow, you know, groups that have direct agreements with them or license agreements with them, which I think will, you know, be a challenge for other tools, not just these assistant tools, but for many other like open discovery tools. And so I think it's a differentiated access, which, you know, is not perfect, but is the world's most comprehensive AI right access across tools. Web of Science, they have all the content. They don't have the rights to just go apply AI to show snippets. They'd have to go renegotiate all these different agreements with publishers, which I think will be hard for them because in many cases, they've negotiated pretty strongly with publishers. And so it's not an easy task to get content from publishers unless you're willing to pay them millions of dollars, right? And we do it really in a partnership with them. And we're continually expanding that partnership, whether that's increasing the distribution of the articles. We also integrate with another tool under our company called Article Galaxy, which maybe some of you are familiar with. So we're you know, enhancing their distribution both in terms of subscription, in terms of tokens, as well as in terms of, you know, views, whether those are buy or rent. And so it's the coverage, I think, is the differentiator, because, you know, if you have an AI that can't access it, it can only do as good as what it can access.
Thank you. I think we end there. Then I have some time to change for our last webinar today. And you, the attendees, you have time, a few minutes to grab a cup of coffee. So thank you again, Josh, for this great presentation and demonstration of Scite.ai. Hopefully we will talk a lot more later and run some more webinars on Scite.ai where we could get a more specific topics. Yes. So yeah, I'm looking forward to it.
Awesome. Thank you so much for the opportunity, and thanks everyone for the questions. And yes, happy to do more webinars or demos on more pointed topics. Appreciate it.